Hello everyone. Previous class I completed the second chapter, that is your structure of atom. In this class I will explain a new chapter, that is your classification of element and periodicity in property. It is your third chapter. Before going to this chapter, I will give some information regarding about this chapter. Before discover of the periodic table, it is very difficult to remember the name of all element. Also difficult to know about the occurrence, method of preparation, different compounds of the element, chemical property, physical property. All the things are very difficult to remember, to learn, to understand. So the scientist wants to discover a method by which all the elements are easily available in a particular source, in particular table, and they are easy to study, easy to learn, easy to understand. So they discovered, they follow the method of arranging to classify the elements. There are more number of periodic tables are discovered, already discovered by different scientists. All the classification of all elements are generally considered as a classification of element. What is the classification of element? The method of arranging similar element together and separating them from dissimilar element is called classification. 118 elements are present in the modern periodic table. Various new elements going on. The discover of new elements day to day goes on increases. Why you need the classification of element? Classification of means arranging the similar elements. Similar elements means the element which have similar chemical property, physical property, or like this. Similar elements are grouped in a particular grouped and placed in a particular place, and dissimilar elements are separated from the similar elements. The separation of the similar elements and the dissimilar elements are generally considered as the classification of element. Why we need the classification of element? There are different benefit of classification of element. The classification of element arranges all the known element in an information RE, in an information block, in an information table. We can say that. So it is very easy to know about the elements and different characteristics. So here we can say that what is the first benefit of classification of element? It arranges all the known element in an information RE. Second is it rationalizes the known chemical fact about the element. Third is it describes the structure of atoms, specifically the arrangement of electron. Next benefit is it predict the order of chemical reactivity and many other property of known elements arranged in vertical column and horizontal row. When you will see the different periodic table, then you easily feel these are the benefit of the classification of element. There are different periodic tables are already discovered by different scientists. So let's move to the history of development of periodic table. This is the said to be one periodic table, that is your Dobereiner triads. Look at that. This is your Dobereiner triads. What is the basic rule of the Dobereiner triads? How the elements are arranged in the Dobereiner triads? All three elements. Look at that. Here, three elements are present. That is your first element, middle element, third element. There are four triads are present. So, if you think about the three elements, all three elements in a triad had similar property, and atomic mass of the middle element of each triad is very close to the arithmetic mean of other two elements. Let me explain this is the meaning of this principle by giving example. Think about the triad one. This is your triad one. Here the first element is your lithium, having atomic mass is your, that is your 7. Middle element is your sodium. Third element is your potassium. If you will sum the, here I have given extra table. This is lithium is the first element, sodium is the second element, potassium is the third element. Lithium having atomic mass, that is your 7, sodium having atomic mass 23, potassium having atomic mass 39. If you will add the atomic mass of first element and the last element, that means I am talking about the mean atomic mass of lithium and potassium, then this is the mean atomic mass of lithium and potassium. Atomic mass of lithium is your 7, atomic mass of potassium is your 39. So here I can write 7 plus 39 divided by 2. You can easily find out the mean. Summation of all divided by number of species. If you will solve this, then you will find 23. It is the mean of atomic mass of lithium and potassium. Look at that. Here, atomic mass of sodium is also 23. Mean of atomic mass of lithium and potassium is your what? 23. Atomic mass of sodium is also 23. Look at that. From this discussion, it is clear that the arithmetic mean of the first element and the last element, sorry, the arithmetic mean of atomic mass of first element and the last element is equal to with the atomic mass of the second element. So here a point given, the atomic mass of the middle element of each triad, here middle element is your sodium, is very close to the arithmetic mean of other two elements. Other two elements means lithium and potassium. Again, verify in the second triad. Look at that. Here the first element is your lithium, second element is your strontium, third element is your boron. Calcium having atomic mass is your how much? That is your 40. All known about this atomic mass of calcium is your 40. Can you say what is the atomic mass of strontium? Yes, you can say that atomic mass of strontium is your 88. Similarly, you can also say that atomic mass of barium is your 137. According to the principle of Dobereiner triads. Now find first, what you will find first? Find the last element. So mean of atomic mass of calcium and barium is how much? 40 plus 137 divided by 2. 40 is of calcium, 137 is the atomic mass of barium. So if you find the mean of atomic mass, then you can say that 177 by 2. If you will solve this, then you will find 88.5. 88.5 is a mean atomic mass of calcium and barium. Look at the table. Here, strontium having atomic mass 88 and the mean is your 88.5. These are nearly equal to each other. Just there is a difference of 0.5. So here we can say that 88.5 is nearly equal to the atomic mass of strontium. It again satisfies the principle. Similarly, you can think about the third triad: chlorine, bromine, iodine. Atomic mass of chlorine is your 35.5. Atomic mass of iodine is your 127. Mean of atomic mass of chlorine and iodine means 35.5 plus 127 divided by 2. You can find that 162.5 divided by 2. That is your equal to 81.25. Look at that. Here 81.25 is the what? It is the mean of atomic mass of chlorine and iodine. Look at the table. Bromine having atomic mass is your 80. They are also close to each other. The difference is your 1.25. Here the difference is your 0.5. Here the difference is increased. That is your 1.25. However, the mean of atomic mass of bromine, the mean of atomic mass of chlorine and iodine is, however, closer to the atomic mass of bromine. Here also a fourth triad is given: sulfur, selenium, tellurium. There is a difference of two. Selenium having 78, mean is your 80. That means Dobereiner triads make a relationship between first element, middle element, third element. As per the Dobereiner triads, he said that mean of arithmetic mean of first element and the third element is equal to the middle element. That is your atomic mass of middle element. One benefit. Let's move to the next. If you think about the property, whether you think about the physical property or chemical property, there are different many numbers of physical property, many numbers of chemical property. Melting point. Can you say what is this? It is a physical property or chemical property? Boiling point. Can you say what is this? Density, oxidation, reduction. There are different types of properties are available. If you think about the property of first element, think about suppose the property of lithium, and think about the property of potassium. What may be the property of these two elements? There is a variation. There will must be a variation. Since they are present one triads, so from the initial it is said that all three elements in a triad have similar property. Why? In triad 1, you can find lithium, sodium, and potassium. Why other elements are not present here? Because this is due to the similar property. Lithium, sodium, potassium having similar property. Like you think about chlorine, bromine, iodine, they have also similar property. So they are placed in a another triad. Calcium, strontium, barium, they are also having similar property. So they are placed on another triads. Similarly, you think about sulfur, selenium, tellurium. Let me explain another point. What may be the physical property or chemical property? About the third element, potassium. What may be the chemical property or the physical property? Listen carefully. The property of the sodium must be in between the property of lithium and potassium. Let me think about the melting point of lithium. Maybe I do not know what is the exact value. Since it is a metal, obviously it have a more melting point. Suppose 2000 degrees centigrade. Suppose I do not know exact value. Potassium having melting point is your 205. The melting point of sodium must be present in these two values. Similarly, you think about the density, oxidation property, reduction property, like this, you can think on any other. That means that the property of the middle element must be in between the property of the first element and the property of the third element. This is the another benefit. Triads helps to categorize the elements. Look at that. Here, lithium, sodium, potassium are present in one group, and chlorine, bromine, iodine are present on the another group, another triads. This is said to be classification of element. Similar property are placed in one position. Here in one triad, dissimilar property are present in another place. Here present in the second triad. Like that, third triad, fourth triads are available here. Here a point already I have given. The property of the middle element were also between the other two elements. This is Dobereiner traits. Let me explain another periodic classification of element. Look at that. This look like what? This look like a spiral, and if you see this is a look like a cylindrical cylinder. One type of cylindrical structure. This is called Chancourtois or Telluric screw. It is also called Telluric screw because it look like a screw. Are you know about the screw which are one type of nail? They are spiraling cut. Next, helix. Yes, it is also look like a helix structure. That is your proposed by Dichan Courtiers. Since it look like a screw, telluric screw, helix, there are three names. You can call this Dichan Courtiers periodic classification, telluric screw, or helix classification. But remember, this is the first real periodic classification. This is the first real periodic classification. It is not an imaginary, it is an real. This cylindrical structure is made by different elements, and the elements are arranged according to the increasing order of their mass. Look at that. If you think about hydrogen, if you think about next is your helium, obviously atomic mass of helium is greater than hydrogen. Similarly, think about lithium, arranged according to the mass. And remember, they are in a form of cylindrical table of element to display the periodic reoccurrence. Reoccurrence means repetition. Let me explain what is the meaning of this. If you think about the lithium, look at that. Here, the position of lithium is here. If you want to make a circle, then you move complete this. Yes, this is. Look at that. If I will start from this position, I will go like this. I will again go. I will cover the nitrogen, oxygen, then I will cover the neon. Next, I will cover the sodium like this. Are you are you getting my point? That means think about the lithium. You want to make a circle, then the circle must be completed sodium. Similarly, start from sodium, go and again. Then when you will reach add potassium, then you complete a circle. In the first circle, you will find the beginner is your lithium. Next is your sodium. When you will go another circle, then next is your potassium. What may be the property of lithium that is repeated in also potassium, in also sodium. Similarly, suppose think about beryllium. Start your journey from beryllium, go boron, next carbon, next nitrogen, next oxygen, next you can think about fluorine, next neon, next sodium, next you will come to the magnesium. When you will reach At magnesium, then you will complete a circle. Similarly, go another circle. Go start your journey from magnesium, aluminum, silicon, phosphorus, sulfur. Next is your chlorine, argon, potassium, calcium. Then you completed a circle. That means here you can say that in the first thing is your beryllium, then you will reach at magnesium, then you will reach at calcium. What may be the property of beryllium? Then it is changes from you will come to the boron. Again it will changes to carbon. Next nitrogen. If you will go one atom to another, then the property will vary. The property may increases, may decreases. There is a regular trend. Remember, sometimes some exceptional properties are irregular in trend. From barium to boron, there is a slight the property may be decreases, may be increases. Slightly decreases. When you will go boron to carbon, then the property of beryllium is again slight more changes, maybe decrease, maybe increase. When you go to the nitrogen, then it again changes. Here again more changes. When you will reach at oxygen, here also changes. When you will come to magnesium, the same property you will find. Similarly, move another circle, aluminium. Next, go to the phosphorus, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. When you will reach at calcium, the same property will again repeat it. That is called reoccurrence of property of element. Similarly, you can think about the carbon, silicon, that is your titan. Here you can say that Ti, G, like that you can think. Similarly, you think helium, neon, argon like this. Oxygen, sulfur, you can think about this. So, here Dechancourtois helps to give the elements which have similar properties. Which element will show similar property? Suppose I will ask a question. Can you say which element? Which element? Try to understand. Try to listen my question. Which elements are having similar property like oxygen? You can suddenly say make a circle. Then when you will reach at a sulfur with each other. Similarly, you can think about suppose I will think about fluorine. You suddenly you make a circle, then you will say that it belongs to the that is your chlorine. Let me explain again. This is the benefit of D. Chancourtois. This is your said to be D. Chancourtois periodic classification. Next thing about the new law octaves. It is a very interesting classification of periodic table. All know about all know about the seven. That is, you can say that seven notes. All know, all can sing a song. Everybody, maybe a bathroom singer, maybe a professional singer, all know about the word, the notes that is sa, re, ga, ma, pa, dha, ni, sa. Actually, there are seven notes. The last sa is just come to make a complete. The eighth note automatically attached. All know about that. This is your song symbol. This is guitar. You can think about anything, but maybe I do not know. Musical notes. First note is your what? Sa. Second note is your re. Third note is your ga. Fifth note is your pa. Sixth note is your dha. Seventh node your knee, and eighth node that is your sa. Actually this is the other scale. This is the first node of the second set. Scale, not. When I will go to the sa, it gives a proper sound. When we will shift from sa to re, then it gives another note, another, that is your sound. Next, move to the ga, it again changes. Ga, next ga to ma will change, ma to pa change, ma to sorry, pa to dha change, ni to dha to ni change. When you will come to the eight notes sa, again their sound will same, that is your similar. Your sa make a similarity like the musical notes. The elements also vary property. The property of the elements will vary like the musical. When you go to, this is your say to be John Newland law of octaves. This is the classification of elements. Here some elements are given. He classified eight groups: first, second, third, fourth, like the musical notes. When you will think about the elements, the property will changes like the musical notes. So this is said to be Newland law of octaves. Here a principle is given. The elements are arranged in the increasing order of their atomic masses. Obviously, think about this table. When you go to the hydrogen to lithium, the mass is changed, increase. Next, lithium to beryllium, beryllium to boron, boron to carbon, nitrogen, oxygen. Automatically, the mass is increased. Next, go to the oxygen to fluorine, will again change. Next, look at that. Your sodium is 23, magnesium is 24. Like that, you can think about the mass will increase. Atomic mass is increased. The elements are arranged according to the increasing order of their atomic mass. Look at that. Here, hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen all belongs to the first node, that is your star. So they have the similar property. Similarly, you can think elements. Actually, this periodic table shows their validity up to calcium. Maximum similarity will found up to calcium. Other elements are listed in the table, but 100% they do not show the merits of this table. This this is come true for the element up to calcium. Again, return to the principle. And the property of every eight elements are similar to those of the first element. This relation is known as law of octaves due to similarity with the musical. Why this is called law of octaves? Because similarity with the musical scale. What? Sa, re, ga, ma, pa, dha, ni, sa. First note is your what? Sa. Eighth note is your also sa. Think about this. Here also given Li, Sa, beryllium, Re, boron, Ga, carbon, Ma, nitrogen, Pa, oxygen, Dha, fluorine, Ni, sodium, Sa. Again, Sa I will repeat. Here we can say that lithium, sodium, and potassium resemble to one another. They are resemble in property. Similarly, boron, aluminium, carbon, silicon, like this. Actually, these tables are not clearly explain all the things. When new element goes on discovered, then the validity of the periodic table goes on also decrease. Because these tables are prepared as per the number of element already discovered. When new element will come, then the table goes on lose their validity. Now time will come, many elements will discover, and the modern periodic table unable to explain all the things, unable to satisfy their the actual aim of actual target. So new table will discovered by any scientist. So next go to the another Lothar Meyer arrangement. Lothar Meyer arrangement. This is said to be Lothar Meyer atomic volume curve. By table. This classification based upon this graph. This graph is made by two parameters. One is your atomic mass, another is your atomic volume. Atomic mass is taken in the x-axis, atomic volume is taken in the y-axis. This is the curve. When the elements are arranged in the increasing order of their atomic, here also atomic increase of the atomic mass. Similar physical and chemical property appear at a regular interval. Look at that. If you think about the helium, look at that. There is a when we go to from hydrogen to helium, atomic volume will increase. Again, it atomic volume decreases. Lithium, beryllium, boron, next carbon like this. Again, increase nitrogen, oxygen. This is a graph. Here also some demerits also present. Also some merits are also present. This is your said to be Lothar-Meyer arrangement. When the elements are arranged in the increasing order of their atomic masses, similarity in physical and chemical property appears at a regular interval. Clear? Next is your Mendeleev periodic table. What is Mendeleev periodic table? How will you show the Mendeleev periodic table? Let me explain. Look at that. This is your Mendeleev. Actually, about the Mendeleev periodic table. Here the elements are arranged as per the in the atomic mass. This is your Mendeleev periodic table. Here, look at that. This is your Mendeleev periodic table. Here, 8 groups are present. Group I, double I, triple I, IV, V, VI, V double I, V triple I. Here, 6 periods are given. 1, 2, 3, 4, 5, 6. Remember, the Mendeleev periodic table is one of the demo. It helps to the classification of the modern periodic table. The modern periodic also like this. There is a improvement of the Mendeleev periodic table. We can say that modern periodic table is the improved Mendeleev periodic table. Difference is in modern periodic table, the elements are arranged in the increasing order of their atomic number. But here, Mendeleev periodic table arrange the elements according to the increasing order of their atomic mass. Here, 8 groups are present. Each groups again classified into two parts: A, B. Here A also B, here A also B. They are separated each other. Look at that. This is your A part. This is your B part. Similarly, this is your A part. This is your B. You can classify like this. Here also you will find A, B. You will find A, B like this. Clear? Here no here transition series. Listen. Here two words is given. One is your oxide, another is your hydride. Think about one element that is suppose lithium. If you think about the hydride oxide of lithium, then you can write Li2O. Similarly, sodium, that is your Na2O. Next is your potassium K2O. All the oxides are written as R2O. Yes or no? So here R2 is given. You can think also RH. Think about the RH. Suppose think about hydride of lithium LiH. Next think about hydride of sodium NaH, potassium hydride KH. Clear? All the hydrides, remember, all the hydrides over that is your RH. Obviously, this is your said to be RH. All the element present in this group are obey this R2O RH. Oxides means R2O, hydride means RH. Similarly, think about the double I group. Oxide is your RO. Obviously, you can write that is your barium oxide BeO, MgO, like this. If you think about the hydride, you can write BH2. That is your you can think about MgO, like write this. Similarly, think about the group Lothar, that is your oxide is your R2O3. Obviously, you can write B2O3, L2O3, like this. RH, you can again write LH3, BH3. Clear? So here RH3 is given. Similarly, think about RO2, CH4, carbon. Carbon is your given CO2, carbon dioxide, SiO2. Next, you can think about SNO2, PbO2, like this. So here, what? RO2 is given. Similarly, think about the RH, obviously CH4. Next, SiH4. This is given by Mendeleev. Next, think about PH3, like this. Think about the VI group. Here, RO3 is given, RH2 is given. You can think about the side also group, that is your what? VI group. You will find same V7, R207, RH, group 8, RO4. You will find a good relationship. You know about the oxides of knowing the oxides of one element, you can think about the oxide of other element. What may be the formula of the oxides? Fourth, first series, that is your second series, you can have potassium, calcium, scandium, titanium, vanadium, chromium, manganese. This is already found in the modern periodic table also. When you will see the modern periodic table, there is a similarity. You will find there is a similarity. You can easily find the similarity. Clear? This is your said to be same thing. Will there is a similarity, some slightly different as compared to the modern periodic table. You will also will get same that is your properties, same features. Let me explain clearly about the Mendeleev periodic table. Basically, this is a 3 mark question. In exam, it will come 3 mark. State and explain Mendeleev periodic law, and write the demerits and merits of Mendeleev periodic table. Basically, Mendeleev periodic table is completely based upon the Mendeleev periodic law. Mendeleev periodic law means the physical and chemical property. Basic, the Mendeleev periodic table completely explain vastly about the physical and chemical property. The physical and chemical property of element are periodic function of their atomic masses. That means indirectly it is that the elements are arranged in the periodic table in the if you will go to the hydrogen to lithium, lithium to beryllium, boron, carbon, nitrogen, look at that your atomic mass goes on increases. Next, this periodic table has 6 periods. Horizontally, the rows are called period and the columns are said to be group. 8 groups are present already. I have seen you. That is your said to be period means horizontal row, 6 periods, 8 group. Then, what are the merits of this periodic table? Why this periodic table is popular during this time? Mentally predictable, you already have seen there are different problem are found. You know, it is also difficult to apply such type of periodic classification to other discovered elements. What are the benefit of Mendeleev predictable? It helps in the simplification of study of element and their compound. Obviously, know about the lithium, sodium, potassium, rubidium, cesium, they are present in a group. You clearly saw that the oxides of these elements by simply know remember R2O. By no, when someone saw that carbon is present in IV group, then you completely saw that what is the oxide, what is the hydride. Follow RO2, RH, RH4. By knowing the element, the presence of the row, the period and the group, you find the element and you will easily also explain about their compounds. This is the first benefit. It helps to the simplification of study of element and their compounds. Look at that. Here some vacant space are found. That is your you can say here also vacant space. Here also vacant space. There are various vacant spaces are found. After again, I want to read. There are some vacant spaces. Before the discovery of new element, the Mendeleev predicted that the element would occupy the vacant place. After few years of his prediction, these elements were discovered and fitted into the vacant place in the periodic table. After presenting the Mendeleev periodic table, Mendeleev saw that some vacant places are present in my periodic table. In future, these vacant spaces are covered by the new elements. He have given the prediction, but after few years, the new elements are discovered and the vacant spaces are filled by the new element. So when Mendeleev published, when Mendeleev presented the periodic table, he already predicted that new element will discover and the vacant place will fill. Next, just like you can think about the scandium and germanium. Actually, when Mendeleev prepared the periodic table, scandium, this is scandium, another is germanium. Actually, there was a vacant place. Here also there was a vacant place. Mendeleev said that the very important merits because it gives the prediction of the discover of new element. It helps the scientist to discover the new elements, keeping the concept of the vacant place. The scientist motivated and discover the new elements. Next point is your It helps in correcting the atomic mass of some elements based on their position in the periodic table. You can think about the beryllium. There are different methods to find out the atomic mass of an element. I already covered this in the first chapter. Basic concept of chemistry. You know about the atomic mass. What are the methods for the calculation of the atomic mass? Mendeleev in this table says that the atomic mass is a 9. What is 9? Atomic mass is equal to equivalent mass into valency. Equivalent mass is your 4.5, valence is your 2. This is one method. Experimentally also another method, 13.5. Experimentally it is seen that beryllium, look at that. Another method is also says that beryllium having atomic mass is your 9. 9 is rectified by following this method. Atomic mass is equal to equivalent mass into valence. Beryllium also have atomic mass 13.5. It is found in experimentally. Suppose I will think about the atomic mass of beryllium. Mainly arrange the elements according of their atomic mass. So after lithium, beryllium is present. Lithium having atomic mass 6.939. Boron elements are arranged according to the increasing order of their atomic mass. There are two value we'll find. One is your 9, another is your 13 point. If I will think about the atomic mass of beryllium is 13.5. Try to understand. If I will take the if I will take the atomic mass of beryllium is your 13.5, then you go against the Mendeleev periodic table, because Mendeleev periodic table says that the atomic mass of beryllium must be in between lithium and boron. Yes or no? If I will think about 13.5, then it is impossible to place the beryllium in between lithium and boron. It must be present after carbon. Carbon having atomic mass 12.011. Already Mendeleev placed beryllium. So you cannot say the atomic mass of beryllium is 13.5. If you will take atomic mass of beryllium is 9, then it is fitted. It support the Mendeleev periodic table. If you will take 13.5, it go against the Mendeleev periodic table. So indirectly Mendeleev periodic table helps to the correct the atomic mass of beryllium. There are different methods for calculation of the atomic mass. One method gives 9, another method gives 13.5. 9 is taken because Mendeleev periodic table supported to 9, not 13.5. So here a point is given. It helps in correcting atomic mass of some element basis on their position in the periodic table. Here I have given that is your atomic mass of beryllium is corrected from 13.5 to 9. Then let me discuss what are the demerits of the Mendeleev periodic table. First point. Suppose I will ask a question. Hydrogen present in group 1 first period. This is your hydrogen. Yes or no? Suppose I will ask you why not you start from this position. Here bromine having atomic mass. Chlorine, bromine having the oxidation number is your 1. Look at that. Your RH, your RH. Then so here a doubtful is created basing upon the position of hydrogen. So first demerit, doubtful position of hydrogen in first and seventh group. of periodic table. You can place the hydrogen in the first group, or you can place the hydrogen in the seventh group. This is the doubtful position. Some elements, actually the main concept, what is the main aim of the classification of elements? Similarly, will placed in particular place, dissimilar elements placed in another place, they are separate to each other. If they having similar property but placed in different period and group. Look at the table. There is the silver. You can find the silver here. It is present in the first group and fifth period. There is the thallium. It is present in the sixth period, and that is your group. Our what was our target? Our target was placing the element which having similar property. Thallium is present in the silver is present fifth period, first group. These are different. They are not placed in a particular period or particular group. Their group and periods are different to each other. So this was also determined. Like this, another example also found in this periodic table. Similar elements are few, no doubt are present according to their similarity, but some elements are present in different position. So 100%. It does not tell about the position of isotope. When isotope is discovered, discovered, it cannot give the position. Suppose a thing about carbon. So C13 will present, where C14 will present. It only thing about the carbon. C12 gives any space for the isotopes. Fourth point is the increasing order of atomic mass was not always obeyed. From the initially, it is said that the main principle is the physical and chemical property are the periodic function of their atomic mass. That means the elements are arranged according to the order of their atomic mass. Look at that. In this table, you will find many demerits. Hydrogen 1.008, lithium 6.9 something, beryllium atomic mass increase, boron 10.8, carbon 12, nitrogen 14, oxygen 15, fluorine 18, already correct. Sodium 22, 23, magnesium 24, aluminum 29. Look at that, look at that. Your magnesium 24.3, your silicon 28.09, your aluminum is 29. 20 to 29. Again, here increase, here also increase. Look at here also. You can find barium, cobalt, nickel. Barium 55.85, cobalt 58.93, nickel 58.71. Look at the 55.85 to 58.93 increased. Okay, correct. Cobalt to nickel, the atomic mass suddenly decreases. So it doesn't obey the increasing order of their atomic mass. You will find in many example. So 100% atomic increasing order of the atomic mass is not followed. So here if demerit is given, the increasing order of atomic mass was not always obeyed. Here I have given cobalt is placed before nickel. No attempt have been made to separate metal from here. Only you can think about the oxide hydride. There is a mixing of metal and non-metal. Let me say. Think about you can see. Look at that. Carbon. What is carbon? Carbon is a non-metal. In this group, lead is a metal. Silver, SN is metal. There is a mixing of the metal and metal. Particularly, Mendeleev do not give a particular place. This is your metal, this is your non-metal. But in modern periodic table, all the element present in the left side are generally metal, in the right side non-metal are present, in between metal are present. When I will discuss the modern periodic table, I will show you given to explain the cause of periodicity among the element in which periodic table. In modern if you will see the modern periodic table, there is an increasing order, decreasing order you will find, and here also you will see the cause why the increasing takes place, why the decreasing takes place. You will see, but in modern periodic table, in Mendeleev periodic table, such type of thing will not find. So the next demerit is your what? It does not explain, it does not give the cause. Periodicity does not explain the periodicity. Next is there are several vacant places in his periodic table which violate the periodic classification of element. Obviously, look at that. I will see you. If you think about this group, potassium, rubidium, cesium found. Look at that. This is your gap. But if you think about the subgroup B, this is your periodic table. There are this periodic table is based on the atomic mass, so it does not give any knowledge about the structure of atom. Obviously, if you think about the modern periodic table, the elements are arranged according to the increasing order of their atomic number. Atomic number gives about the number of electron, number of proton for a new atom, the number of electron proton same. If you will know the atomic number of an element, then you will saw the number of electron present in the element. If you will saw the number of sorry, if you will know about the atomic number of an element in the modern periodic table, then you will saw that number of electron, because atomic number is the number of electron present in an atom for a neutral atom. Yes or no? But in case of ion, the definition is changed. The definition will change. But for a neutral atom, we can say that atomic number is equal to the number of electron. When you will know the atomic number of an element in the modern periodic table, then you can say that the number of electron present in the atom. Again, we know that the number of electron is equal to number of proton. If you uh, if you uh, if you already known about the number of electron, then you will easily find the number of proton. So by knowing the atomic mass, by following the atomic mass, you cannot satisfy the electronic configuration. That means the structure of atom. You cannot say the arrangement of the electron around the nucleus. There are three elements placed together in the group double I. Look at that. If you will see the Mendeleev periodic table, look at that. Here, two subgroups, each group having two subgroup. But if you think about the group B double I, here only one group. And in one group, all the elements, three elements are present. Your two elements are present, your three elements, some group are also filled by only one element. So there is no similar entrant. There is a dissimilarity. So these are the different demerits. Again, I will repeat. First demerit is your doubtful position of hydrogen. Second is your similar property are placed in the similar sorry. Second is your the element having similar property are present separately. Next, third is your it does not tell about the position of isotope. Fourth is your increasing order of atomic mass was not always obeyed. Next, fifth is your no attempt has been made to separate metal from non-metal. No explanation was given to explain the cause of periodicity. Next, there are several vacant places. Next, this periodic table is based on atomic mass, but it is not beneficial for the for knowing the structure of atom. There are also three elements present in group Vi. These are the demerit. Thank you everyone for watching this video.